All right, so are you ready to like explore the physics of free fall?
I am.
We're going deep today with some really cool resources.
Awesome.
And they're all about like interactive simulations and stuff
Oh, cool.
to really like bring these concepts to life.
I like that.
It's not just about like memorizing formulas.
Right.
It's about getting that like aha moment
Yeah.
where you actually understand how objects behave
Sure.
when gravity takes over.
Exactly.
So the resource we are diving into today
Okay.
is called Open Educational Resources /
I've heard of this.
Open Source Physics at Singapore.
Yeah.
Have you heard of it?
I have, yeah. It's a website that uses interactive JavaScript simulations to teach physics.
It's super cool, right?
It is.
And the best part is that like anyone can access these resources.
I love that about it.
It's like totally free.
Yeah.
You don't have to like sign up for anything.
It's like they're democratizing physics education, right?
Yeah.
Making it accessible to everyone.
And like one of the things I find really fascinating about this website is how they approach kinematics.
Okay.
So like instead of just defining it, you know,
Right.
they actually use it to help us understand the motion
Uh-huh.
when gravity is like the main force.
So it's like figuring out how things move when the Earth is like pulling on them.
Yeah.
Exactly.
That's a good way to put it.
And they have these simulations
Oh,
where you can explore free fall
okay.
both with it and without air resistance.
Oh, wow.
So you can see how things change
Interesting.
when you add that extra layer of complexity.
Yeah, that makes sense.
And the simulations use graphs, right?
Yes,
Not just equations and formulas.
they do.
They use like displacement time
Mhm.
and velocity time graphs
Right.
to help you visualize the motion.
It's like seeing the story of the object's movement unfold, like right there in front of you.
Yeah, it's pretty cool.
It is.
I remember struggling with those graphs back in school,
Oh, yeah.
but now I'm kind of excited to see.
Too. How they make sense in these simulations.
Yeah.
Speaking of things I remember from physics class,
Okay.
what about that whole acceleration due to gravity thing?
Oh, yeah.
It's not just gravity pulling things down.
Right.
It's like making them speed up too, right?
Yeah, that's a really important concept to grasp.
Yeah.
You see, it's this constant acceleration
Okay.
that allows us to predict how fast something will be falling.
At any given moment.
Yeah, like at any given moment.
That's so cool.
It doesn't matter what it is.
Right.
Like it could be a feather,
A feather or a piano.
a piano.
They'll both be speeding up by about 10 meters per second every second.
So it's like this universal rule
Yes.
that governs how everything falls on Earth.
Precisely.
Wow.
Now, things get a bit more interesting
That's
when
right.
we bring air resistance into the mix.
Yeah, yes. Air resistance.
That feeling you get when you stick your hand out of a car window.
Right.
I imagine that plays a huge role in how things fall,
It does.
as an object falls faster.
Air resistance pushes back harder,
Uh-huh.
and this leads to a phenomenon called terminal velocity.
I remember that term.
Yeah.
It sounds kind of dramatic, though.
Little bit, yeah.
Like it's the end of the line for a falling object.
It's not quite as dramatic as it sounds.
Okay.
Think of it more like reaching a speed limit while falling.
Okay.
It's that point where the force of air resistance perfectly balances the force of gravity.
So it's less about gravity like losing
Right.
and more about reaching a kind of truce with air resistance.
That's a great way to put it.
Okay, I like that.
And this truce.
Terminal velocity.
Yeah, this terminal velocity isn't the same for everything.
Right.
It depends on the object's shape,
Size. Yeah,
and the density of the air.
that makes sense. Like
Yeah.
a feather's going to have a very different terminal velocity
Right.
compared to, say, a bowling ball.
For sure.
And these simulations, they let you see that all play out right.
Yeah.
You can actually like tweak the variables
Yeah.
and see how things change.
Exactly.
So you can adjust the size and shape of the falling object
Yeah. You could.
and essentially change its surface area.
Right.
And then you could see how that impacts its terminal velocity.
It's really cool.
Or you could even tweak the density of the air itself.
Exactly. You have a lot of control.
That reminds me of those old wind tunnel videos.
Oh, yeah.
But in these simulations, we can actually control the wind, right?
Yeah, we can crank up the air resistance
Yeah.
and see what happens.
Exactly.
That's awesome.
It's a really cool way to get a visual understanding
Yeah,
of how these factors interact.
I agree.
So we've got kinematics,
Mm-hmm.
graphs,
Yeah.
acceleration,
Mm-hmm.
and air resistance
So coming together
all coming together.
in these simulations.
It's like having a virtual physics playground
I like that.
right at your fingertips.
Yeah, it's a great analogy.
And the website doesn't just stop at the simulations, does it?
No, it doesn't.
I noticed they also have specific learning goals.
Yeah,
and resources for teachers.
they do.
It's very comprehensive.
It is.
They outline clear learning goals,
They do.
encouraging students to analyze graphs,
Yes.
describe motion under different conditions, and really dig into the nuances of free fall.
It's great for teachers.
And they also provide teachers
Yeah.
with worksheets
They do.
and example problems,
Yeah.
making it a truly collaborative learning tool.
I love that about it.
Speaking of real-world examples,
Okay.
let's shift gears a bit
Sure.
and talk about how all of this applies to situations we encounter every day.
Okay.
You know, beyond just dropping things off a building.
Right.
I remember they mentioned skydiving in the materials.
Oh, that's a good one.
You know, if we ignore air resistance for a moment,
Okay.
all skydivers,
Mm-hmm.
regardless of their weight,
Oh.
would fall at the same rate
Right.
because of that constant acceleration due to gravity.
Exactly.
So in a vacuum, everyone would be plummeting towards Earth
I know. It's crazy.
at the same speed.
It is wild.
But we know that's not how it actually works.
We do.
Right.
Right. And that's where air resistance comes in to complicate things.
It always does.
It does.
Air resistance always has to, like, mess things up.
It does make things interesting, though.
That's true.
And you know what's really fascinating?
Right.
Even though skydivers experience the same acceleration due to gravity,
Okay.
the distance between them actually increases as they fall.
Wait, really?
Yeah.
Why is that?
It's because they each reach slightly different terminal velocities.
So, like, the skydiver who's all spread out like a starfish
Yeah.
is going to fall slower
Exact.
than the one who's, like, tucked into a tight ball.
Yes, because they're creating more surface area
Okay.
and encountering more air resistance.
So they're truce with gravity.
Their terminal velocity
Yeah.
is reached at a slower speed.
That's so cool.
And that's just one example of how
Mhm.
air resistance affects free fall in the real world.
It's amazing how these, like, seemingly simple concepts
Yeah, right?
have such complex implications.
They do.
When you apply them to real-life scenarios,
It's true.
it makes you realize how important it is to
Yeah.
understand these fundamentals.
You got it.
Speaking of fundamentals,
Yeah.
what other real-world applications did the materials highlight?
Well, they also talked about the classic physics problem
Huh.
of a tennis ball being thrown upwards from a building.
Oh, yeah, I remember those problems.
Yeah.
They always seem so abstract to me.
Right. But they're actually a great way
It's a-
to see how the principles of free fall can be used
Right.
to predict exactly how an object will behave.
Like, you can calculate how long it takes
Mm.
for the ball to reach its maximum height
Yes, exactly.
and its velocity at different points,
You got it.
and even its position after a certain number of seconds.
That's right.
So it's not just about understanding the concepts in a vacuum.
No.
It's about using them
Yeah.
to make accurate predictions
Exactly.
about the world around
I
us.
like how you put that.
And that's one of the things that makes these simulations so valuable.
Yeah, I agree.
They allow you to connect
Yes.
the theoretical
Uh-huh.
with the practical.
It's one thing to read about these concepts in a textbook,
Right.
but it's quite another to actually see them in action.
And manipulate the variables yourself.
For sure.
It's like the difference between reading a cookbook
Okay.
and actually getting in the kitchen
Yeah.
and trying out a recipe.
I like that analogy.
You get a much more intuitive understanding
You do.
of how all the ingredients interact.
That's a great way to put it.
And these simulations aren't just limited to free fall, are they?
No, they're not.
I bet you could use them to explore all sorts of physics concepts.
Oh, absolutely.
Like
what? Well, you could use them to investigate projectile motion, for example,
Okay.
and see how the launch angle and initial velocity affect the trajectory of an object.
So you could basically launch a virtual cannonball
Yeah.
and see how far it goes,
Exactly.
depending on how you aim it
You got it.
and how much gunpowder you use.
Exactly. You can experiment with different launch conditions.
Wow.
And really get a feel for how those principles play out in the real world.
That's awesome.
It is.
It makes me wonder what other scientific concepts could be brought to life
I know, me too.
through interactive simulations.
I think the possibilities are endless.
I think so too.
Especially as technology continues to advance,
Yeah.
we can expect even more sophisticated and immersive simulations
That would be amazing.
that allow us to explore the world around us in completely new ways.
It's really exciting to think about
I know, right?
the future of education
Yeah,
and how these tools can make learning more accessible and engaging.
couldn't agree more.
I'm all for making learning more engaging.
Me too.
especially when it comes to physics.
Yeah, it's too often presented as this dry,
Yeah.
intimidating subject. But when you break it down,
Yeah.
it's really about understanding
Yeah.
the fundamental forces that shape our world.
I think one of the key takeaways here
Okay.
is that understanding freefall isn't just about memorizing equations or definitions.
Yeah.
It's about developing an intuition
Yes.
for how objects behave
Exactly.
under the influence of gravity and air resistance.
I love how you put that.
It's about seeing those patterns in the world around us, recognizing the forces at play,
Yes.
and appreciating the beauty of how it all works together.
That's beautifully said.
We've talked about skydiving and projectile motion.
Yeah.
What other examples come to mind?
Well, consider the design of parachutes.
Okay.
Engineers have to carefully consider the factors influencing air resistance to ensure a safe and controlled descent. They need to calculate the parachute's surface area,
Okay.
its drag coefficient, and even the weight of the skydiver
Wow.
to determine the appropriate size and shape of the parachute.
So it's not just about strapping on a parachute and jumping out of a plane.
Not at all.
There's a whole lot of physics involved
There is.
in making sure you land safely.
It's true.
Understanding free fall is crucial
It is.
for designing effective parachutes.
Absolutely. And it's not just limited to skydiving.
Okay. What else?
Think about sports like baseball
Okay.
or basketball.
Okay.
The trajectory of a ball thrown or hit
Right.
is heavily influenced by gravity and air resistance.
So a basketball player taking a free throw is actually doing some pretty complex physics calculations in their head
In a way, yes.
without even realizing it.
They're intuitively factoring in those principles of free fall
Wow.
to determine the best angle and force to launch the ball towards the hoop.
And even something as simple as dropping a feather
Yeah.
and a bowling ball from the same height demonstrates the concept of air resistance.
It does.
You can visually see how the feather, with its large surface area, is slowed down much more than the dense bowling ball.
Exactly.
It really is incredible. It is. How these physics concepts
I know.
are woven into so many aspects of our lives.
Yeah.
From the seemingly mundane to the extraordinary.
It's like physics is this secret language of the universe.
I like that.
And once you start to understand it,
Yeah.
you can see it at work everywhere you look.
And by exploring these concepts and engaging with simulations, we can unlock a deeper understanding of the world around us.
It's like opening a window into the hidden workings of nature.
And who knows, maybe by understanding these principles, we can even unlock new possibilities and innovations for the future.
It's exciting to think about.
But that's a conversation for another deep dive, perhaps.
Perhaps.
For now.
Okay.
Let's shift gears
Sure.
and head into the final part
Okay.
of our freefall exploration.
Sounds good.
Okay, so we're back
We are.
to the final descent of our freefall deep
I
dives.
like that.
We've covered a lot of ground
We have.
from those basic principles
Mm-hmm.
to real world applications.
It's been quite a journey.
Now, before we wrap things up,
Okay.
I want to make sure we've really hammered home the key takeaways.
That's a good idea.
It's easy to get caught up in the fascinating examples and simulations,
Right.
but having a solid grasp of the fundamentals
Yeah.
is what really allows you to understand the physics at play.
For sure.
So let's do a quick recap.
Okay.
What are the absolute must-know concepts
Okay.
when it comes to freefall?
All right. Shoot.
The things that'll make our listeners the life of the party
Okay.
at their next physics-themed gathering.
Love it.
All right, so first and foremost,
Yeah.
true free fall only happens in a
Okay.
vacuum,
Right.
where gravity is the only force acting on an object.
Okay.
Like that classic feather and hammer experiment on the moon.
Oh, yeah.
They hit the ground at the same time
They do.
because there's no air
Right.
to mess things up.
It's beautiful, isn't it?
It is.
So this means no matter what the object is,
A feather,
a feather,
a hammer,
a piano,
a piano,
a car,
they all accelerate downwards at the same rate,
they do.
thanks to that constant acceleration due to gravity.
It's amazing.
Roughly 10 meters per second squared.
Yeah.
It's like the universal language
I love that.
of falling objects.
I do too.
But, of course, as we've been discussing,
Yeah.
we don't live in a vacuum.
Sadly, no.
We've got air, we've got wind.
All those real world factors
There are all those real-world factors.
that make things a bit more complicated.
They do.
So that's where air resistance comes in.
Air resistance.
That force that pushes back against objects as they move through the air.
And the faster they fall,
yeah,
the stronger that pushback becomes.
Exactly, until eventually
you reach that point of equilibrium.
That terminal velocity.
That terminal velocity.
We were talking about.
Speed limit for falling objects.
Like that.
A truce between gravity and air resistance.
And it's important to remember.
That terminal velocity isn't like a one-size-fits-all kind of thing.
No, it's not.
It varies, depending on all sorts of factors.
It does.
The object's shape, its size. Even the density of the air it's falling through.
Exactly.
So a feather,
yeah,
with all its surface area and lightness,
it's so light,
is going to have a much lower terminal velocity
for sure,
than a bowling ball.
Definitely.
The feather gets a lot more pushback from the air.
It does.
While the bowling ball just powers through.
It just keeps going.
This is all starting to click now.
Good.
It explains why a skydiver needs a parachute to slow down.
Right.
Or how a baseball player can throw a curveball.
It all comes back to physics.
Freefall physics is all around us.
It is.
Even if we don't always consciously think about it.
That's true.
It's the reason things fall the way they do.
It is.
And understanding those principles can help us make sense of the world.
It really can.
Well, I have to say, this deep dive has been a real eye-opener for me.
Good.
I feel like I've finally grasped those freefall concepts that always seemed a bit fuzzy before.
Yeah, they can be tricky.
But before we say goodbye,
okay,
I always like to leave our listeners with something to ponder.
I love that.
A question that sparks their curiosity.
All right.
And keeps those physics gears turning.
Let's hear it.
So for our deep divers out there, consider this. How would understanding free fall and air resistance apply to designing a spacecraft for re-entry into Earth's atmosphere?
Ooh, that's a good one.
Think about the intense heat generated by friction.
Yeah.
The need for a controlled descent.
Right.
And that delicate balance between slowing down enough to survive, but not burning up in the process.
Talk about high-stakes physics.
It really is.
Right.
It's amazing to think that understanding those freefall concepts we've been talking about could be the difference between a successful mission and, well, disaster.
It really highlights how crucial these seemingly basic physics principles are.
Yeah.
Not just for understanding our everyday world, but for pushing the boundaries of exploration and technology.
Well, deep divers.
Yes.
We've reached the end.
We have.
Our freefall adventure.
Sad to see it go.
I hope you've enjoyed exploring these concepts with us.
Me too.
Remember, physics isn't just about equations and formulas.
No, it's not.
It's about understanding the fundamental forces that govern the universe around us.
I love that.
So keep asking questions.
Yes.
Keep exploring.
Please do.
And keep diving deep into the wonders of science.
Couldn't have said it better myself.
Until next time.
Bye.